Alright, so Pythagorean Theorem Converse and classifying triangles. It says Pythagorean Theorem Converse because I'm going to show you some other stuff you can do with the Pythagorean Theorem. Y'all know Pythagorean Theorem as a squared plus b squared equals c squared. Yeah, that's the one you use if you're trying to solve for a missing side on a right triangle. But you can also use the Pythagorean Theorem to prove what kind of triangle you have if it's not a right triangle. Say a triangle is acute. You can use the Pythagorean Theorem to prove that the triangle is acute, which means all the angles are less than 90. Y'all should know that. Or you can prove the Pythagorean Theorem also to show that a triangle is obtuse. You just write it a little bit differently. So we'll start with the one that y'all know. Regular Pythagorean Theorem. You know it as c squared equals, and I'm putting the c squared first. I'm doing it for a reason on this. A squared plus b squared. If that's the case, then you know that your triangle is a right triangle. Alright. Let me zoom out so you can see all at once. So if you have c squared equals a squared plus b squared, which y'all should all be familiar with, then your triangle is a right triangle. If you have the case where c squared is less than a squared plus b squared, then that means your triangle is an acute triangle. And all that means, your c squared, remember that's your hypotenuse, your longest side. If the longest side is less than the two legs squared and added together, then you have an acute triangle. All you do is solve it out, compare the numbers at the end. If it's less than, it's acute. And then obviously, going the other way, if c squared is greater than a squared plus b squared, then the triangle is obtuse. Alright. So that's the Pythagorean Theorem Converse. The converse part is these two here. So here, c squared is less than a squared plus b squared, or c squared is greater than a squared plus b squared. So this part right here, part of it's going to feel very familiar. 1, 2, 3, and 4. We've done this before. Let me read the directions for you. First, it says always keep c squared on the left side to avoid confusion when classifying. It says first determine the three side lengths first determine if the three side lengths could form a triangle. Recall from earlier, the sum of the two smaller sides must be greater than the third side. If yes, then classify the triangle further as acute, right, or obtuse. So the first part we've done before, and y'all should remember how to do that. Y'all remember how we checked to make sure a triangle was a triangle? Somebody tell me what we do. You got three numbers. No, we just checking to see if a triangle is a triangle. You got three sides. How do we check to make sure this is a triangle before we do anything else? You don't add them all up. Yeah, you do what now? Exactly. She just said it. Say we're going to add 3 and 7, and if that's greater than 9, then it's a triangle. Remember, your two smaller sides have to be greater than the larger side. If that's the case, then it's a triangle. If it's not the case, then it ain't a triangle. You got to check to see if it's acute, right, or obtuse. Because if it's not a triangle, what you checking for that for? So the first part, you're just checking to make sure that this is a triangle. 3 plus 7 is 10. 10 is greater than 9. So yes, we have a triangle here. So this is a triangle. Then after that, we want to check to see what kind of triangle it is, acute, right, or obtuse. This is the new part right here. This is you checking to see if it's one of those three things. So what I'm going to do, I'm going to use the formula up here, but I'm going to leave the symbols out because I don't know which symbol I'm going to use in the middle yet because I got to check the numbers. So I'm going to say c squared, leaving a number out. I put a question mark last period, but let's keep it open. No, let's put a question mark again. I like my question mark. C squared, question mark. We don't know what goes in the middle. A squared plus B squared. My bad. So c squared question mark because we don't know what sign goes here. A squared plus b squared. But y'all should know what numbers go in. What should c squared be based on the three numbers given? 9. So 9 squared question mark. We still don't know our symbol. Then a and b. 3 squared plus 7 squared. Alright, then solve. Solve this side, solve this side. This side you get 81. On the other side, 3 squared, 9 plus 49. 9 plus 49. Anybody can do that math in their head? 58. So you got 81 and 58. What sign should go in the middle? 81 is what? Greater than 58. Based on that, what triangle do you have? Obtuse triangle. Anybody confused about what we just did? You shouldn't be. Most of it is stuff we've already done. This is the only new part right here, and it's really just this end part that's new. If your hypotenuse is greater than your other two sides added together, then it's obtuse. If your hypotenuse is less than the other two sides added together, then it's acute. If it's equal, you should already know it's right. We've been through that. What's up? Ask me your question. Then the other word. Kind of all goes together. We just showing you this first. If you look, we're going to the graphs down here in a second. And then on the back, that's when we're going to use the graph to check 30, 60, 90, and 45, 45, 90. The stuff we've been doing. It's all, I told you, it all compounds on itself, man. Y'all don't be believing in me. I'm trying to tell y'all. Number 2. Y'all probably going to go ahead of me and do these, but it is what it is. Is it a triangle, first of all? Yeah, it's a triangle. 20 plus 21. 41. 41 is greater than 29. This is a triangle. Then after that, check to see what type of triangle it is. C squared, question mark, A squared plus B squared. Put the numbers in. C squared is 29 squared, question mark, A squared, 20 squared plus 21 squared. Y'all gonna have to give me those numbers. These numbers kind of big. You know what I actually remember from last period? This was 841, if I'm not mistaken. Question mark, 400 plus 441. Add those together, you get 841 over here. 841. What is it? Thank you, sir. This is a right triangle. Yes, sir. Moving on. I'm moving fast because I think this is easy for y'all. Which one? Number 3? Why is it not a triangle? Yeah. 15 is less than 16, so this is not a triangle. So once you get that figured out, you ain't got to go no further. What's up? Take the two smallest numbers. That's the two smallest sides of your triangle. Add them together. If they less than the bigger side, then you don't have a triangle. Two smaller sides of your triangle have to add together and be greater than the bigger side. Can't be less than or equal. Number 4, 17 plus 17, 34. So that's greater than 22. We good. This is a triangle. Then you just figure out what kind it is. Honestly, before you start, well, and they may ask you this at some point too. Just based on the numbers, classify this by its size. I ain't asked you this, but what kind is this? Let me give you the options. Scalene, isosceles, equilateral. Yeah, just by looking at the numbers, you could tell there's isosceles, at least. Then you just got to classify it as acute, obtuse, right? $22 squared. Oh, question mark. 17, 17. I need these numbers, I can't remember. Oh, never mind, I got it right here. 484. What y'all classified it as? Yeah, 484 is less than 578. Yeah, so this is acute. Yep, that's the first part. So that's how you would classify a triangle. They gave you the sides, and they wanted to know if it's acute, right, or obtuse. I know for a fact there'll be a question like this on the test, but all you have to do is check. You just have to remember how to do that when you get to the test. Next Friday. Well, hopefully. I don't know. It depends on how Trig go tomorrow and Monday. I usually spend more than 2 days on Trig, but here they only like to spend 2 days on it. I might add another day in, but I don't want to test y'all on a Monday, so I don't know. I have to figure that out. Right now, the test Friday. It could change. Not this Friday, obviously. Next Friday. It might change, though. I don't know. We'll see how Trig go tomorrow and Monday. All right. Down here at the bottom, classify triangles by its sides. Recall, equilateral triangles have 3 congruent sides. Isosceles have 2 congruent sides. Scalene have no congruent sides. Classify each triangle by the side lengths. We've done this before already, too. This ain't nothing new. Graph. -2, -3. 6, 1. 3, 7. You with me, Bobby? Got to do a wellness check on you, man. That's my figure. Now I know most of y'all, when we did this last time, y'all kind of like cheated and eyeballed it. Eyeballing this, you know, is definitely not equilateral. It could possibly be isosceles. More than likely it's scalene, but we got to check that. What I was telling them last period, though, to save you time, because honestly, on this, if all you're proving is that it's one of these 3 things, you don't have to give values. They're not asking you to find the length of each side or find perimeter. So once you get 2 of the sides and it becomes clear that it's probably not going to be, equilateral or isosceles, you can just answer the question. But at least do some kind of check. Don't do nothing. Don't be like the key some of y'all did last time we did this. Leave the whole figure blank and just write a word over here. That's not going to work. Show some kind of work. Like for me, these are 2 sides I'm concerned about right here. I don't know if they could be equal. They probably not. This one looks a little bit longer, but I'm going to check anyway. I know this side right here is definitely longer than the other 2. So I'm just checking to see if it's isosceles or not by these 2 sides. Making my triangles. Y'all should remember this. I'm going to do AB first. Anybody counted that? Which one? No, I'm saying what's the 8 and 4? That's what you took. My bad. So 8 horizontally and 4 up. Okay. What's the count on BC? 6 and 3. Thank you. So I'm going to do Pythagorean on both of those. Just make sure they're not the same. More than likely it's not going to be. But just showing some kind of work will help me out. 8 squared, 4 squared, c squared, 8, 64, 16, c squared, that's 80, square root of 80. I'm going to just leave it like that for now, because we don't need, or like some of the kids said, they were like, can we just get the decimals? Yeah, on this, if you're just checking, see if your sides are congruent, it don't ask for it in simplest formula. You don't need to, like I said, you don't leave the numbers other than proving that the sides are different or whatever. So you can't get decimals. Last period, they gave me decimals for these. I think for this one, they got 8.94. Let's see. BC, 3 squared, 6 squared, c squared, 9, 36, c squared, 45, square root. It gave me 6.7 for this one. Like I said, by the time you check those two, obviously those lengths are different. This other length here, this looks way longer than both of them. You could check that one if you wanted to, but this is good for me. At least you did some kind of check. This would be a scalene. I don't know, we're gonna write it down here. Scalene. Don't make me do number 6. You do number 6. I want to do the ones on the back. On number 6, you only got to do Pythagorean on 2 of the sides. The side AC is vertical. And honestly, I'll save you time on that one. I'll do it with you. 2, 5. 3, -3. So on this one, AC, you could have just counted. On the 2 sides, you would need to get a length on where this one here, AC. You see how from A to C is vertical? You can just count that by counting on the graph. The diagonal ones we can't count, Christian. Because you can't count. Oh, no, I'm telling you, I ain't know if you was asking or not. You ain't say nothing, Kylie? You lying? She said she ain't say nothing. So on this one, before you show work, you might be wasting your time. Like I said, obviously AC is longer than the other 2 sides, yes. And then once you do This will be enough work to show right here. Once you do the actual triangles, and you see this is 8 and 5, and then this side is 5 and 4, you know it's going to be scalene. Because these numbers would have had to be the same. It had to be 5 and 4, or 5 and 4, or 8 and 5, and 8 and 5 for that to even work out. So by the time you do that on this one, this is fine for me. Scalene as well. Alright, on the back, this way it gets a little bit different. By the time I did 7 and 8 for them last period, they got the hang of it. Let's see if y'all gonna catch this. So on the back, you classifying, but you're not only classifying if it's scalene, equilateral, or isosceles. You also classifying if it's 45, 45, 90, or 30, 60, 90. So this way you're going to have to refer back to your 45, 45, 90 stuff and the 30, 60, 90 stuff after you figure out. Now, what type of triangle is a 45, 45, 90 triangle? I know it's right. What else? I'm asking you for a reason. Isosceles. So when you first prove, if you when you're doing this, if you see that when you get your numbers that your triangles are isosceles, then after that, that's when you go and check if it's 45, 45, 90. By checking the 45, 45, 90 stuff, and I'm gonna show you that. But if you're doing this one, what kind of triangle is a 30, 60, 90 triangle? Scalene. So if you prove when you're doing this, if all your sides are different and it's scalene, then you need to go back and check and see if it's 30, 60, 90. If it's equilateral, it's neither. Just making sure you understand. Alright, so graph A, -3, -1. B, -3, -3. And then 1, 0. I'm glad we made these smaller, make it easier for us to count. So my first side, AB, you can see that's vertical. So you can just count that. What's the length of AB? 2. After that, BC, need to get that side. So I want to do Pythagorean on that. That's 4 and 3. So BC, 4 squared plus 3 squared equals C squared. 16, 9, C squared. 25, square root, 5. So the length of BC is 5. So AB is 2, BC is 5. Need to find AC real quick. What up? Hold on. 1 else to count 4. Yeah. So AC, that last side, do that one. 1 squared, 4 squared, 1. What's that? 16. C squared, 17. C squared, square root. On this one, I'm going to just leave it as radical 17. You know I can't break that down, and I don't want the decimal right now. Since I'm comparing 45, 45, 90, and 30, 60, 90, I'm going to leave this as a radical. So I'm going to say radical 17 equals C. So AC would be radical 17. So it's definitely what? Scalene, definitely scalene. Since it's scalene, you want to check real quick to see if it's 30, 60, 90. The easiest check I can tell you for the 30, 60, 90 is thinking about the relationship between the short leg and the hypotenuse. What's the relationship between the short leg and the hypotenuse on the 30, 60, 90? It's times 2, right? So short leg is half of whatever the hypotenuse is. So short leg in this triangle would be AB. The hypotenuse would be BC. Compare those two numbers. AB is 2, BC is 5. Is that good? No, BC should be 4, right? If that was that relationship. So automatically that makes it a no. So you ain't got to go no further. So it's not a 30, 60, 90. The only thing this one is a scalene. And we would know from even looking at it, if you look at it, it has no right angles in this scalene. You need a right angle in there anyway for it to be 30, 60, 90. So this is just a regular scalene one. That's the check you would want to do. You alright? Wish I can. Alright, this probably the last one I do. The other two are going to be on you. Number 8. The vertices of ABC are... Why am I reading that? Graph that. I'm about to read points to y'all no more. A. Tyree, you graph this shit? Oh man, I missed. Not my best triangle, but it'll work out. Alright, so none of these are on here straight, so you gotta do the triangle, do your right triangles for all of these. You do this side. This side. Then this one. Counts are 2 and 1, 2, 3, 4. Huh? 1 and 3. Say it one more time. That's what we about to find out, only. You gotta check. You can't just assume that. So if you're looking, it's definitely isosceles. You should be able to see that. Because if you see from A to C and BC, those two numbers are saying you got 1 and 3 and 1 and 3. I'm still going to solve because I need to compare these numbers. But when I do AC and BC, I'm only going to do it once and just write the same number twice. So I solve for AC, and whatever I get for AC, I'm going to just write that down for BC. So AC, 1 squared, 3 squared, equals C squared. 1 plus 9 equals C squared. It's not scalene, bro. Square root, square root. You should know what I'm doing. Yeah, I'm going to leave that at square root of 10 because that's the simplest form. You can't break square root of 10 down anymore. 5 and 2, and they're just going to go right back together. So, what is it? BC is the same as that, so BC would also be square root of 10. So AC and BC are both square root of 10. Then you need to find AB. AB, 2 squared, 4 squared, and C squared. You doing this, this Friday? You already done? 20, C squared, square root, square root. I forgot I wasn't showing y'all again. My bad. I'm just checking that longest side. So I get square root of 20. I can break that down, but I'm going to leave it like that for now. Just because I want to compare it to the top one and the other legs anyway. So like I said, this is definitely isosceles. Isosceles is not a choice over there. You got to check and make sure it's 45, 45, 90. For 45, 45, 90, y'all should know by now what the relationship is. On the 45, 45, 90, my two legs were square root of 10. If I got the legs and I want to know what the hypotenuse is, how do I find the hypotenuse on the 45, 45, 90? Take a leg and times it by square root 2, right? So just to do a check, my leg was square root of 10 times that by square root 2. I get square root of 20, yeah? And then AB was square root of 20. So this is a 45, 45, 90 triangle. You just need to make sure you do the check to make sure that works out. All I did was take one of these two legs up here, square root of 10 and square root of 10, and times it by square root of 2, which is the rule. And that gave me square root of 20, which I already had right here. So this is a 45, 45, 90 triangle. That's the check you need to do. Do 7 and 8, see what they are. 7 and 8, 8, 9, and 10, my bad. What? I don't know. What you want? What part you want? Remember so I found all three sides first. You remember the rules for the 45, 45, 90. A leg, well, the hypotenuse is the leg times square root 2. So I took one of the legs, which was square root of 10. My square root of 10, that was my two legs. And I just times it by square root 2. Once I got square root of 20, which I already had for my hypotenuse, I know for sure that it's a 45, 45, 90. You understand? What you want? What's this? Make sure you sign your full name, sir, no abbreviation. You did the other one? You ain't write square root of 34. How you know though?
You just said it.
How you know? How you know it's 45, 45, 90?
Okay.
I want you to explain it to me. I ain't saying you wrong.
What you mean? So it is wrong?
I ain't saying you wrong. I want to tell me how you know.
Because these two are not the same decimal.
You ain't supposed to.
And then these two are the same. First of all, if they look outside, I did a room.
Get away from me,
It's
Owen.
right.
Yo, you ain't finished the work to actually prove it, but yeah. You gotta finish
We
it.
got it right.
Well, y'all charging that up here and unplug my computer card. Y'all be trying me, boy. That's what. Y'all unplug my stuff?
No, it's on the top one.